Alright, I looked at late code. I don't know how the hell to do it, so whatever. I want to work on my kind of thing anyway. So, let's try to figure out what the administration algorithm is going to be. I am writing a Japanese vocabulary program, but it has a twist. I am going to force users to read kana, not Romaji, and can't fall back to, what the hell am I trying to say? To audio. So, every time they read a word, they are not only being tested on remembering the word mapping, but also on every unique kana in the word. It is kana only, no kanji for this program. Okay. With that context, how many times do you think a word would need to be repeated in a 30-day period? Keep in mind that the user will have many opportunities to review kana in other words. So we can probably fall back to normal language acquisition. Okay, so what I was originally thinking was Fibonacci sequence on a number of seconds, except I would start with 1. I wouldn't start with 0, 1. But that's still, if that was the number of seconds, that would still have you repeating 30 times in a month. I don't know if that's too much. Maybe that's perfect. I don't know. This is a neat design choice. Forcing kana reading means you get free kana reinforcement on every word review, which genuinely changes the math compared to typical SRS. Does it, though? Does it? Because I said we can probably fall back to normal language acquisition. For your actual question, in a well-tuned space repetition system over 30 days, a single word a learner sees for the first time in 1 day is typically reviewed 6 to 8 times. If they're getting it right, 10 to 15 times if they're struggling. Okay, that jives with my intuition. And then there's always the really weird edge cases, like the 1 in 100 mental block and the 1 in 400 mental block and the 1 in a fucking lifetime mental block that I had that one time, but we won't get into that right now. Okay, standard SRS intervals, Anki's default super memo derived for a successfully learned card look roughly the same. 1 to 3 days during initial learning, then 1 day, 3 days, 7 days, 16 days, 35 days. Over 30 days, that's 6 to 7 exposures for a card that's sticking. Add a couple more if the learner lapses once or twice, which is normal. This is the band most mature SRS apps converge on because it targets roughly 85 to 90% retention, which is the sweet spot information theoretically. According to Piotr Wozniak, and more recently the FSRS algorithm. Both land here. Okay. Now your twist. Because every word exposes blah, 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 you don't need to independently drill kana. In a vocabulary of even a few hundred words, any given kana will appear across dozens of words. So a learner reviewing 20 new words a day will hit each of the 46 base hiragana many times per day just incidentally. Yeah, but not if I'm easing them into it. That's exactly how natural reading acquisition works. frequency of exposure, and varied context, so you can safely not add extra kana-specific reviews on top of word reviews. The kana will take care of themselves for anyone doing meaningful volume. One caveat worth designing around is rare kana. What is that? Ne, mu. No, that's not ne. Oh, maybe I struggle with rare kana too. Is that mu? No.
Ne.
Ne. Ne, mu, ne, re, ro are often confused. The fuck is that? The fuck is that?
E.
I have never seen that in my entire life. What the hell? It looks like Sanskrit. It doesn't look like it. Okay, whatever. Sorry, getting carried away. You won't get the same incidental exposure because they appear in fewer words. You might want to either way early vocabulary to cover. Okay. I think you are right. I can ignore kana so long as I order the words in the right order such that review comes naturally and things are introduced incrementally while still covering everything by, I don't know, 2/3 of the way through so that all kana gets reviewed eventually. For rare kana, we can just kind of stick that at the end of or something. Unless, no. Yeah, that's the right instinct. It's a solvable ordering problem. A few thoughts on how to approach it cleanly. The chlor technique. The chlor? Are you okay, Luke? The core technique you want is incremental introduction with coverage constraints. Basically, order words so each new word introduces at most 1 to 2 kana. I was thinking strictly 1, but 1 to 2 is fine. The learner hasn't seen yet, and every kana gets locked in, seen in and distinct words before you move on. This is how Haze 6 remembering the kanji works for kanji and how Duolingo roughly structures vocabulary trees. Applied to your case. Early phase, say days 1 to 7, prioritize words that use the most frequent kana. Say the top 25 hiragana by frequency. No, I, e, u, shi, ta, de. Well, I don't need to read them all. You can pack a surprising amount of vocabulary into that subset. Each word here covers maybe 2 to 3 kana the learner has already seen, plus introduces 1 new one. Middle phase, days 8 to 20, expand the full base hiragana set. Okay. Each kana should appear in at least 3 to 4 distinct words before day 30, ideally spread across different weeks so natural SRS review picks them up. A kana that only appears in 1 word is fragile. If the learner forgets that word, the kana goes 2. Don't introduce more than 1 new kana per word in the early phase. This is the Heisig principle. It keeps cognitive load on the word. Okay. I think I have enough words that I shouldn't ever have to introduce more than 1 new kana except maybe literally the very first word. But maybe that's naive. Okay. It's actually achievable. There's a subtle trap worth knowing about. The math is on your side. With 46 base hiragana and a decent-sized vocabulary pool, say it's 500 plus words, which is exactly what I have, you have a massive combinatorial room. Japanese has lots of 2 to 3 kana words, and the frequency distribution of kana is skewed enough that common kana recombine in tons of ways. Okay. This may actually be easier than I thought and probably won't require a CUDA simulation. Come on. Okay, let's try to figure out what it is that we're even looking at here. Actually, close other tabs. Update manifest. And we'll go fetch kana like this. Okay, hiragana manifest path. And we're going to have words, and this will be words, but for right now we're not using this one, and it won't be update manifest. It'll be with open UDF8. Thank you. I think it should be data though. So let's see, print length data. See how long this is run. 501. I will admit, I thought I had more words than that, but it said 500 plus, and we are definitely above 500, so yeah. So let's see, print data 0. So the first item here is like that. Kana units. Okay, so we'll say C equals counter. Alright. And then we'll say for item in data, and then for kana in set item, except it's not kana, it's kana units. And the set makes it unique, and so that's what we're going to have. So print C. So 500 words. I really thought it was more than that. Kind of bothers me. Okay, so ugh. I wonder if these things that appear, what would I really be losing if I removed just these? Not much, right? Okay. I ran this. And got this. Okay. Good data, and there's some real issues worth flagging here before you build a scheduler. The good news is you have 501 words and 67 distinct kana units represented, all base hiragana plus dakugent. Oh. These are variations of existing kana. If people learn the rules, well, not that one, but the real problems are in the tail. Each appears in exactly one word. This is fragile. If the learner forgets that single word, the kana effectively disappears from the review cycle. You really want every kana in at least 3 to 4 distinct words so SRS can do its job. Being at 1 is especially surprising. It's a directional particle and shows up constantly in real Japanese. If your list is vocabulary only, no particles, that explains it. That's exactly what it is. Still won't recognize in sentences. Worth a design decision. Well, I just need to introduce sentences. どこへ行くんだよ? I don't think that's how you'd say that. Well, good thing I'm not trying to teach anybody Japanese, huh? They're also thin. Is a very common kana. Your list seems to be underrepresenting it. The handuketen row is uniformly weak. 1, 1, 2, 5, 9. Total of 18 word appearances across all 5. Learners will genuinely struggle with these because they'll barely see them. In real Japanese, these are less common. Is your list missing any kana entirely? Well, absolutely, because I have 104. One more diagnostic worth running. How many words are reachable with the 1 new kana? If the answer is basically all of them, you're golden. If there's a disconnected cluster of words, yeah. I think we can use the ordered frequency as a heuristic to decide which to introduce and only deviate if there is an exception. Unless you think that's a bad idea. It's a reasonable heuristic and it'll get you 80% of the way there, but it has one specific failure mode worth understanding before you commit to it. Why it mostly works. High frequency kana. I know that it's not guaranteed to work. The failure mode is frequency doesn't equal connectivity. Imagine 2 kana both appear in 20 words, but they're different words. Yeah, I got it. I understand. Score candidate kana. Pick the kana with the highest unlock count. Ties broken by raw frequency. This is still greedy and still fast. Your pool's 501 words. Trivial to recompute. Where raw frequency is actually fine. Wait, hold on. Are you suggesting building a map where words are represented as 1 or less changes to a set of kana? Or did I misunderstand? Okay, you just named the structure more precisely than I did. Let me make it explicit because it's actually a clean formalism. Yes, it's a graph where words are nodes and edges exist between words if they differ by at most 1 kana. Their kana sets have symmetrical differences, less than or equal to 1, or more precisely for your case, 1 word's kana is a subset of the others, plus at most 1 new kana. This is essentially a word graph under a +1 kana reachability relation, and your curriculum is a traversal of it. That is so much smarter than whatever the hell I was thinking. So, reachability check. Run this. Reachability check. Seed kana set. Kana units. Enumerate words. What is it expecting? Data? No. Yes. Yes, it is. Where is W coming from? Data seed kana set. The hell is seed kana set? Is it actually a set? Where is it used? Oh, I see. Seed kana set is confusing me. Like this. Parameter is doing something sneaky and you're right to question it. What I was imagining is you pass the kana from your chosen first word. Because word 1 unavoidably introduces multiple kana at once, you can't have a 0 kana word. Yeah. Alright. What you're looking at in the outputs. Okay, reachability check. Okay, and now we do. Just data. All right. Okay. Reachable words, stranded and known. Oh, good. Oh, good. Stranded is an empty set. So we're gold. I'm gonna go get some more drink. All right, I'm back. I got more ginger tea now. All right, tune the weights, inspect the outputs, adjust. Okay. Greedy unlock count as the base scoring function, plus a few constraints penalties for the pedagogical concerns above. Something like minus penalty if confusion pair is too recent. Bonus if handokuten and late enough in curriculum, plus the full scheduler, or inspect the greedy output first. Yeah, it's fine. As long as our initial word is the shortest length possible, and we're not introducing new kana too quickly, I don't think it really matters. What I don't want is all kana exposed in the first 60 cards, because we didn't spread it out. That is more important. It's a much better framing of the problem, and it changes the algorithm meaningfully. You're not optimizing for unlock as many words as possible, as fast as possible. You're optimizing for even kana introduction across the full curriculum. Those are different objectives and can actually conflict. Yes, I know. That's why I said something. Okay. What you actually want is a pacing target, something like introduce a new kana roughly every n words. (501 words and only 67 kana. That means on average each kana appears in 7.5 words, which matches your data, median around there. So most words in well-paced curriculum should introduce 0 new kana. Their reviews of already known kana in new combinations. Only 67 of the 501 words should introduce new kana introduction. The other 400... If the curve is linear, the pacing is working. Try running this to check. Let's see what it gave us to run. Scheduled data. Oh, right. I didn't print anything. Does it think I'm working in Jupyter Notebook? Is that what's going on? Plot this should be roughly linear. Total unique kana known after word I. Print introductions. C is not defined. My bad. All right. I can't plot it because I'm not in Jupyter Notebook. Should I move to Jupyter Notebook? No need for Jupyter. I can visualize this for you directly. Let me show you the curve. Alright, I can take this opportunity to remove my tea bag. Ow, that's hot. Ow, ow, ow. You know, they gave me some, like, bamboo prongs to get it out with. I don't know why I'm using my hand. Here, next time I'm using the prongs. Alright. This curve is close to ideal. The actual introduction rate tracks the ideal linear pacing almost perfectly. A few special observations. Early phase, slightly ahead of target. You hit 20 kana by word 50, where linear pacing would predict 17. This is basically unavoidable and actually fine. Early words need enough kana variety to form real vocabulary, and the first word alone contributes 1 to 2 kana for free. No need for Jupyter. Hold on. let me swap out the data set for katakana and see if the trend holds. All right. Repeat, please, with the katakana. I got the jiggle leg going. I'm shaking the whole desk. Hopefully you can't hear that on the microphone. The trend does not hold for katakana. The curve looks very different from the hiragana one, and there's a real problem here. The curriculum is longer than hiragana. Looks like 600 plus words versus 501. That's fine on its own. The curve tracks the ideal line reasonably well through about word 400 reaching 67 kana. Then it flatlines at 67 for roughly 160 words. That's a quarter of the entire curriculum spent in pure consolidation with no new katakana. Finally, there are two brand new katakana introduced at the very end, jumping from 67, 68, 69 in the last two positions. The two late introductions are the actual bug. These two katakana are getting introduced with essentially zero SRS review. Alright. They won't get repeated enough. My guess is they're actually maybe a rare handakuten or... Can you check? Mochiron! Ass. This is a fixable data problem, not a curriculum problem. None of these five are genuinely rare in Japanese. They're just underrepresented in your work pool. Okay. Legitimately uncommon in native-ish katakana words, but show up in plenty of loan words. Okay. Very common. Yogurto, Europa, mayonnaise. All right. Evidently, two words means a learner who forgets one of those effectively loses the kana. Suggested additions. Pick 2 to 4 kana, you only need to nudge the counts up. That's 15 to 20 additional words, and it fixes the problem completely. I mean, the truth is, we rejected 1,400 words. Where's our rejected words? There is no corresponding JSON for the rejected words. These are all single characters, right? Let's see, active cards. Where the hell did I put it? Katakana MP3. Oh, no, that's not it. Where are they? Open in Explorer. Katakana words. This is my final batch. Where was my earlier batch? Oh no, did I delete it? I bet I did, didn't I? Kana singles. I don't know what the hell that is, but that can definitely go. Kana MP3. There should be something with either 2,000 or 4,000 words in it. Oh, you're really starting to piss me off now. I have no idea what this shit is. That's what I get for reusing the same directory. Okay, cards failed. Oh, here we go. Here we go. Here we go. Here we go. There's 2,443 words here. Here. Rejected words equals like this. Okay, now let's do this here. For f in os dot list directory, katakana manifest path no. Like that. Okay, so we're going to say assert f dot ends with dot mp3, and then we will say f dot w equals f dot split period 0, and then we will say rejected words dot append w, and then we will just look at the rejected words like this. I'm not interested in things of length 1, so if length of w is greater than 1, then we add it. All right. Here is a list of words. Generate code to find your 20 dream cards to add to the deck. I employed various strict rules, maybe some of which were too strict. Okay, hard rule. They absolutely cannot introduce new characters at this point. We are filling gaps, not making new ones. I'm missing the actual output. The list isn't in your message. You probably meant to paste it. I really didn't mean to paste it, but I can. Okay. Let's go up here. Where is it? Where is it? Rejected words, rejected words. paste here. Boom, boom, boom. And engage. Okay, selected 20 words. All right. That's a solid list. The algorithm did its job. Every gap is covered. Math checks out. Pedagogical concerns. Proper names dominate. Korean name. Japanese name. Amazon brand. New York is letters. Proper names are genuinely weaker vocabulary because they don't generalize. It's just straight up giving me suggestions. Oh god, that's awesome. Honestly, I probably rejected them because they were proper names. But at this point, I just want the stupid kana covered. Alright. Okay, if I'm going to add these, that's going to be a pain in the ass. Okay, to be completely honest, adding things right now sounds like a pain. Make me a note of cover these, and I will add cards to the hiragana and katakana units later. I have an active project to do anyway. Certainly not impossible, but katakana gaps. Candidate words from earlier analysis use or substitute as preferred. Verification after adding. Rerun the counter plus pacing script. Can you put this into a more easily machine readable text file I can download? I just need the characters. All right. Okay, now what we're going to do is we are going to come over here, not here, Android Studio, update the to-do list to note that the following are gaps in the curriculum, and we need to add about 20 units to 20 words to katakana words and hiragana words, respectively. Okay. Plan.md. I actually want to see the changes that it made. Alright. Okay. That is basically exactly what I wanted it to do. So that looks pretty good. Cool. For now, we are just going to order the hiragana and katakana. I would like to delete my existing script because it is getting crowded. And start from scratch. Let me show you what an object from the JSON looks like. Okay, so over here, okay, so for unit in hiragana, yeah. So they do look very similar. Unit like this. Print item 0. Right? No. Print data 0. Print unit and unit, like that. Okay, now we go run. Okay, it looks like this. So output and then new script. Okay. I need you to use your algorithm to order the existing cards by modifying their priority. Where is it? Yeah. 0 to n-1, where n is the number of items in the unit. Right now they are sequential, but the app will administer in the order of their priority. Alright, when done, write the, what am I trying to say? Write the updated JSON file, ensure ASCII equals false, and indent equals 4. Okay, so I'll let that think for a second. I think I turned off thinking, which was probably dumb, but that's fine, as long as I can figure it the hell out. Now, I think that I should make a backup. So, change directory, do I have it? Yes. Git status, git add, incremental work about to adjust curriculum. That's good. Okay. Alright, first word is the shortest word, fewest kana. This ties broken by commonest kana. This handles the unavoidable multi-kana introduction at word 1 while keeping it minimal. Pacing target is linear. Okay. Only writes valid priority 0 to n-1. I'm just going to run this and I will see the diff. Okay. And engage. Okay. Boom. boom. Okay, I think it's just get diff. Okay, so instead of priority 0, now it's 83. Now it's 89, 376. Okay. Looking at the modifications, it's good. Get looks good, and then the output. We wanted to check the output. Both curves are slightly front-loaded in the first quartile, and then tracked the ideal almost perfectly for the remaining 75%, which isn't particularly surprising because that's what we modified it for, or set it for, configured it for. I don't know what the hell I'm talking about. The fact that the katakana ending up matching hiragana's shape, despite earlier worries, is especially good news. It means that the algorithm handled the gap filling without gap fixing case gracefully. It spread the rare katakana across the curriculum rather than dumping them all at the end, which is probably jarring. And then the user reviewing the words can be the review of the rare kana until I get around to actually enhancing the curriculum. All right. If you want to verify visually later. No, I think we're done here. All right. Okay. I'm a big fan of the Fibonacci series. I think I should use it for word administration. However, if the time increment is 0, or excuse me, is seconds, then that has the user reviewing words about 30 times in a month, which seems excessive. Figure out what the ideal multiplier is for 1, 2, 3, 5, 8, ... such that it matches the expected number of administrations, and then feel free to tell me why this is a terrible idea, and I will rethink my life. I think we should probably turn on adaptive thinking. Thought I clicked that. Maybe it didn't register. Okay. Okay. So we're gonna come over here. Did I commit those? I don't think I did, no. Get status, that's what I expected. Modified priorities of word units to incrementally introduce. It's like, I'm inclined to get lazy typing the commit message, but then it's going to be there forever. I'm never going to change it, so it's just like, whatever, I can type the sentence. Okay. So let's open in Explorer all if the MD files are together. Calculating Fibonacci multipliers against standard spaced repetition schedules. My intuition says that the Fibonacci sequence is good, but there's a problem with intuition, is that sometimes it's shit. So, Fibonacci cumulative sums, yeah. You want a cumulative at target review to be just under 30 days. Solve for the multiplier. Reviews in 30 days. Final review 23.7 days, 8 hours, 12 hours, 24 hours. The bold rows land in the 6 to 8 review. Target range we discussed, 8 hours. Now the reality check. It's not a terrible idea, but here's what you're actually committing to. Fibonacci is just 1.618x exponential expansion. Each interval is 5 times the previous one. That's literally the definition of the golden ratio. Standard SRS algorithms like SM2 use 2.5 expansion for successful reviews. So Fibonacci is slightly more review heavy than the state of the art, which for a beginner learning Kana is probably fine or even good. The thing Fibonacci doesn't do is adapt. This is the actual weakness, not the intervals themselves. Real SRS tracks per card difficulty and adjusts. If you crush the card, the next interval gets pushed out. If you miss it, it comes back sooner. Easy words get... you have to pick one. Ignoring lapses makes the whole system fragile. If they mark a card wrong, it will get reviewed more often, whether the interval is Fibonacci or exponential. But my original design docs called for levels being powers of E. In other words, the number of seconds between administrations is E raised to L, where L is a word level. And I should probably stick with that. Look at my design docs and let me know if anything needs to be changed or updated as a result of our discussion today. Alright, so this is like one chance for Opus to tell me that everything in my life is wrong. Okay. Read your design docs carefully. Good news, very little actually needs to change. Your original E to the L design is sound, and most of what we discussed today is already reflected. Here's the real audit. Exponential space seen with fractional gains. Your step 5 spec gain 1.0 on time, fractional early, drop 2.0 on wrong, mature floor at peak level greater than or equal to 14.66 is a genuinely well-designed SRS. It's SM2-like but simpler. E to the L seconds means intervals of roughly 2.7 seconds, 7.4 seconds, 20 seconds, 55, eventually reaching 14 days. 30 days at L equals 15. That matches the 6 to 8 reviews per month target we computed. Kana non-retreat rule. Your spec that component Kana current level never drops when a word is marked wrong is exactly the right call for the free Kana reinforcement via word review model we discussed. Introduction mode separation, already there. Step 6. Word 1 doesn't need to be a test card. It's an introduction. What is... I don't know what that means. I don't know what this means. Peak level tracking already there. No review history table already documented. What should actually change? Add the Kana gap cards to plan.md step 6. You already did this, but tighten it. Your current note reads gap, add about 20 words each, but the numbers don't match what we finalized. Update the final. I don't give a shit. If I... Okay, you know what? Okay. Okay, that's fine. No, 20 words each, 13 words. It doesn't matter. Okay, I can recompute which words to add at a later time, just like I did today. After adding these, rerun the ordering script. The new... Well, yeah, I will. And then the pacing curve should be re-verified. Add this as an explicit sub-step. I disagree. I think that I can stick them all at the end. And I think that that's good enough. And actually, as weird as it sounds, having more cards might actually be better because it just forces the things to be reviewed. Right now, your docs just... damn it. Should I rerun the script? Okay. Document the curriculum ordering as a build time step. Right now, your docs describe priority as a field, but don't describe how it gets set. Add a section somewhere, like a new file, curriculumtooling.md, or an appendix to agents.md, documenting ordering algorithm, the reachability precondition, pacing verification, gap coverage target. Okay. You are free to write a curriculum tooling MD document, but put a note at the top that it does not affect the Kotlin project, only the external tooling, which is used to update the JSON, which is read-only. This is relevant since Gemini free AI will read that file. And I don't want it touching the curriculum. Okay. Add lapse handling test cases to step 5. Your step 5 test covers on wrong drops by 2.0, which are missing testing strategies. What does not need to change? You don't need to switch to Fibonacci. One thing worth considering. Your docs mentioned property tests. All right. Okay. Return an updated testing strategy.mp, and I will update it in the project. Introduction mode separation. I was just confirming something you've already, not flagging a problem. Your plan.md step 6 already distinguishes introduction cards. First exposure shows both sides. Got it button from the initial introduction. Okay, I do remember designing that. Basically, the first time that somebody sees a card, we don't say, hey, what does it mean, if we don't expect them to know what it means. That can be very discouraging. We have to indicate that it is a new card somehow. Now, the two documents. All right, curriculum tooling. I'd really like to get to administering a card, and I'd like to see if we can get that in there tonight. So we select a unit, and then we select a card. And I might want to use the stronger LLM for implementing the initial card selection logic, because I don't want that to get screwed up. And I think it's pretty friggin' easy to screw it up. Now, the updated testing strategy. I'm keeping your structure intact and adding the scheduler-specific test cases and property tests we discussed. Well, that is very exciting. I am very excited. So, okay, creating updated testing strategy and scheduling property tests. Come on, Agnes. Oh! My alarm's about to go off. Maybe this is a good break time. Okay, let's see. So we're going to download, and we are going to download. Okay, the curriculum tooling did not exist at all. Okay, this is a derivative of PyCharm. So if I'm not mistaken, I should just be able to drag files pretty much directly. Sort by date. There we go. Alright, so and down here? No? Nothing? Refactor and overwrite one of them. That is precisely what I wanted to happen. We have a testing strategy which is modified, and we have a curriculum tooling. Okay, scope. Note for AI agents and automated tooling. This document describes external Python tooling used to author and maintain the curriculum JSON files under Assets Curriculum. It does not describe or affect the Kotlin Android application code. The curriculum JSON is read-only from the app's perspective. The app loads it at runtime but never modifies it. If you are an AI coding assistant, go away. I think we may have overstated it a little bit, but yeah, you know what, that's fine. That's fine. LLMs can be quite stubborn sometimes. So, I think that this looks pretty good. Let's come over here. Git status. Git add curriculum tooling. Git commit -m. Add document about how Kana was, or Kana words were ordered. Git diff. Okay, use property test for invariance. All right, this looks pretty good. All right, I'm gonna say quit. docs. Boring. Boring, boring, boring. Oh no. I accidentally hit the dictation mode and it's been typing everything that I'm typing. At least it didn't auto-send or anything. Okay. So yeah, that looks good. Let's get this agent started here. I'm going to experiment with the more expensive agent, and I might be about to hate my life. But supposedly more powerful. So let's see what it does. Okay. UI should be separated from the data by an abstraction layer to facilitate what? To facilitate testing. We need to create the abstraction layer for units and their associated unit and or and their associated unit and or integration tests. Integration tests. Please implement these now. Before implementing, please read all MD files except curriculum tooling. What the hell? It won't let me select the file name? Oh, you are really starting to piss me off now. Except curriculum tooling as it is irrelevant for implementation. Alright. Yippee-ki-yay. I will let that run for a second. You know, I click allow so many times. I think I need like a little bird, like that Simpsons episode where Homer was working from home and he had a bird that just hit the yes key over and over again. Oh, no. I need OpenClaw. Allow. To run the command. You see, it should always be able to run this. What is this? Which one? Is there like an icon? Little arrow thing. Come on, I don't want to have to click allow every single time. Always allow. Outside the project? Yeah, if it's inside the project, then yeah. Alright, okay. Oh. Detected what I was trying to do and it automatically advanced. That's pretty cool. Yeah. Okay. Still going? I mean, I asked for the easy one. Curriculum repository. So get units, get unit, get items. All right. Previously approved. Change 2 files. What was the other one? All right. It's looking pretty good. Pretty good, pretty good, pretty good. All right. I got sick of just watching it spin, so I've successfully implemented the abstraction layer for your units, lessons, and their associated tests requested. Domain abstraction, data layer implementation, unit test, dependency injection. Everything compiles successfully, and the newly added unit tests are passing. Let me know if you need any. All right. Okay. Well, looks pretty good. Now, where are my configured manage modules? Gemini. Get Gemini API key. Yeah. Billing. Spend. Okay, so what I just did cost 21 cents. I think you can see why, generally speaking, I would probably like to stick with the free model. 21 cents may not sound like a lot, but it's pretty easy to charge things up pretty quickly. So, I mean, that was one thing. I asked for one feature and, charge up 21 cents. So, let's come back here. Not here. Okay. Okay. All right. Once a unit is selected, there needs to be an abstraction layer for marking for, hold on. For telling the system which flashcard to display. These are normally based off levels. Is it normally based off levels? Yes, that's correct. Okay, which flashcard is independent of what constitutes a session? That is to say, it would happily run forever. Even if the user only intended on a 10-minute session. Scheduling should be handled elsewhere. Okay. So, yeah. If nothing is out of date at a high level, If nothing is out of date, we administer a new card. Yeah, we administer a new card. Unless there are no new cards, in which case we administer the most out-of-date card. The user might actually want to review things they know. So this is not considered an error case. We never administer the same card twice in a row. So we need to store last card this session. This should be ephemeral or have a timeout in case the user leaves and comes back. Actually, maybe a timeout from last mark is sufficient for this. Like, nothing within the same 3 seconds or something like that. Yeah. All right. The leveling should be described in the MD documents. Be described in the MD documents. But intuitively, if you get a card right repeatedly, the level goes up and it gets administered less and less frequently. If you miss a word, then the level goes down and it repeats more frequently. There are floors on minimum level defined in the docs. Be sure to make unit tests around these. Alright, let's see what it does with that. Now this is a much harder and more complicated request than I was making of the Gemini 2.5 Pro Limited, and I'm fully expecting it to cost like 50 cents. And you know what? I can pay 50 cents. That's fine if it can implement it correctly and not give me a giant headache. I would expect a simpler model to get confused with me saying that many things. And come on, Google, don't let me down here. Sorry, Gemini, not Google. I get it. I understand the correlation. They're not, tautologous. So I have a writer friend over in the, what does it want to do? Make directory? The hell does it want that for? Oh, it wasn't asking for permission. It was just committing changes. That makes more sense. I have a writer friend over in the UK who makes children's stories for me. Someday I'm going to publish a book. Looks like he has sent me one, so I should probably look at that. It is called Sherlock Holmes and the Bunny Napping Clown. Oh shit, it's long. Oh my god. This is like a full-on short story here. I was expecting like flash fiction or something. All right, I think you get the general idea. I have a feeling that this is going to pass. No, I'm recording the whole process. I'll pause it. There we go. That's what I'll do.
If you didn't know Sherlock Holmes, then this behavior would have been very strange. You might even be sad or angry that he didn't say hello or even seem to notice or care that you'd been away for several months. However, I knew him very well, and for him, this was perfectly normal behavior.
So, apparently, listening to the story, it's about 15 minutes long, which is that's a short story. So, that's awesome. Very fun. I don't know when I'm going to post or publish this children's book. Sometimes I feel bad about using generative AI, and I don't know. I had a friend who needed a writing gig, and I wanted to do educational material, so I just ended up in a situation where he's writing these stories for me. So hopefully I publish it one day and it'll be fun. Okay, let's see. Next card selector. Alright, scheduling strategy, interface, and exponential scheduling strategy. Yeah, what I want to look is I want to look at the tests. That's fine. So here we are. So create item. So these are all simulated, right? Well, that's fine. Yeah, good for flashcards equals true, script equals hiragana, priority equals priority, kana units equals list of. Alright. Never administer the same card twice in a row if alternatives exist. I do like it covering the edge case, because, I mean, if there's literally no other card, then yeah. Yeah. Vastly overdue. Item 1 would normally be picked, comes first in the array, same priority, but same priority. Oh, you see, now it's worrying me. Now I'm getting worried. I am worried that it is not implementing the exponential method at all. All right. Where is the code where the exponential level is used to calculate if a card is out of date? See, it's just specifying a next review ad. The calculation of whether a card is out of date, due for review, is split into two steps to maintain a clean separation of concern as requested by the architecture in agents.md. It's just a link to the file, not to the line. Calculating the future date due exponential strategy.kt. The exponential level is used to calculate the exact future timestamp next review at when the user is graded. This happens in exponential scheduling strategy. So, new level, interval milliseconds, yeah. Oh, and it does prevent against overflow too. Cool. Checking if the card is currently out of date. Next selector.kt. When selecting the next card, the next selector doesn't need to know about the exponential math. It simply compares the saved next reviewed at Timestamp against the current. Okay. Okay, I think I was being paranoid for nothing. I was thinking that that was going to be calculated at the time. It sounds like it's pre-computed, which honestly, that might even be preferable. So, I remember I have this like vague recollection of trying to force a SQL database to do exponential math for this exact reason, because I hadn't stored the next administration. So yeah, that looks good. Let's switch back to default no cost here, and see if we can proceed. All right. Add in the UI unit selection. This should be the first thing the person sees. It will load a unit for doing cards. We can get things like fancy lesson scheduling and stuff later. Moi, je suis très fatigué. Alright, while that's thinking, I will tell my friend that I received his story. I have received your story. I'm not going to tell him I'm listening to it, but not read it yet. Looks good though. Alright. I do need to add it to the spreadsheet though. So let's see, generating response. So that's still working. Okay, let's see. Word count. Where is word count? Right here. 2,679. Still working. Still working. Let's see. Where is my story ledger? Yeah, 2,679. Sorry, I'll stop talking out loud. Yeah, a lot of this AI stuff is just waiting. It's faster than humans, but it's not, it's not like, you know, like scrolling Twitter Firehose or something like that. Okay, so 162, 83. All right. Hiragana, katakana, hiragana words, katakana words. So let's take a look here. Study mode for hiragana coming soon. Seems like it is working to me. Alright, that looks excellent. Excellent. Should we make it select a card? Oh, it's still working. Is it proceeding? Seems like it wasn't ready to go much further than that. Okay. Study mode for title coming soon. It's making it good. Oh, it is proceeding. Is it executing like an actual UI test? I was not expecting it to go this far. I gotta be honest, and this isn't necessarily a bad thing, but it seems like Gemini is much more aggressive with the I'm just gonna do this thing than other models that I've used. I've used ChatGPT 3.5, I've used Opus 4.7. Now, admittedly, those were inside of a different IDE, but behind the scenes, the LLM is the same. And Gemini always catches me off guard. It's like I ask it to do one thing, it's like, well, you know, I was there, so I did this other shit too. Short. Can't speak English. I think it's time for me to go to bed. Okay, I think that looks really good. Let's take a look at it. Correct. E. Yeah, I mean it definitely. Okay. Update the to-do that we need to add sound output. I will work on that later. Will I work on it later? Okay. UI integration. Clicking show answer should play the accompanying MP3 immediately for the user to judge themselves. Please implement. Please implement it. I feel like, I mean, we're like almost there. If we can add this, then like it's basically working. After that, it's just polish. Well, that's underselling it a little bit. I mean, I still need to add the paid mode. Yeah, there's some things I need to do. I shouldn't overstate how close we are, because there's still quite a bit of stuff. And as you get into little trivial things, it can actually start becoming harder, and it can start being a little bit surprising. It's like, oh, all those little things add up. Why, yes, they do. Oh boy. Oh, got me good. That's okay. If that's what it took for it to be implemented right, then, you know what? Can't complain. complain too much. It's all done? Not even close. So I don't know if you're fully getting this, but like this scroll bar is really wonky. And it has pissed me off multiple times in the past few days. And I think it happens when it's adding content while I'm trying to scroll or something. Does this have a volume setting? I mean, presumably it does. I can't tell what it's doing. Sure, I trust you. What are you doing? Alright. Yeah, it seems like... I heard a sound. I feel like I heard a sound. It seems like my application is... It seems like my emulator isn't making any sounds. Do I need to change the configuration to be able to hear it? Maybe I should have asked that in ask mode instead of agent mode. No, it's not. My application is probably playing the sound. The emulator is not making any noise. Oh, for hell's sake. Come over here. In Android Studio, it seems like my emulated device, Pixel 6, I think, isn't making noise when it should. Do I need to do something to map its sound output to my system speakers? My side itches so bad. Usually the emulator routes audio to your host's default output automatically. There's no manual mapping step. If it's silent, it's almost always one of these. Inside of the emulator itself, check the volume. I did that. AVD audio settings. Open Device Manager in Android Studio. Click the pencil. Show advanced. Enable audio. Okay. That is almost certainly what it is. Okay, so where is it? Am I being stupid? Location, phone, settings. Where is it? 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 It wouldn't be location. Simulate headset, voice assist, fingerprint, virtual sensors, bug report. Come on. Device manager. Edit. Oh, here we go. It's got to be in here somewhere. I'm just being stupid. Device. Yeah, it's not that. Camera, network, startup, storage. It's not here, right? Like I'm not losing my mind. Well, how am I supposed to test that it makes noise? Well, I guess I'll have to use my actual regular phone. That is ridiculous. Okay. Device manager. AVD. Did I click AVD? I don't know what AVD is. I feel like I may have seen AVD and I may have skipped it. Because I didn't know what it was. Open in Device Explorer. Like, is it here at like the top? No, it's just not here. It's as simple as that. Okay. Well, I think I'm done tonight. So, okay, see ya.